Hello and welcome to today's class. Okay, today's class on vectors, we have a question on the board. The question says, find the sum of two vectors. We have the first vector A being equal to 5 meters at 60 degrees and vector B 6 meters at 130 degrees. Alright, this is under representation of vectors using graphical form. So let's solve this question and see the outcome of the answer. We can actually add to this question, okay, hence sketch the resultant diagram. But let's solve this first. After this, we'll sketch the resultant diagram. So the solution to this, the first thing you have to do, the solution to this question, is to sketch each vector, alright? To sketch each vector. So the first thing you have to do is to sketch vector A and also sketch vector B. So let's sketch vector A because that's the first vector. Let's sketch vector A, alright? I'm going to draw the quadrant. This is north, east, west, and south, alright? And the quadrant is 90 degrees, okay? Now, to sketch vector A, I'm told that vector A is 5 meters at 60 degrees, alright? Now, I know that one quadrant is 90. Another quadrant is 90. So each of these quadrants are 90 degrees each. Now, please take note, whenever you want to sketch the angle of a vector, it must always be inclined to the x-axis. So it means that if I'm drawing the angle, it must always come from the x-axis, alright? So to draw the angle for vector A, the angle for vector A is 60 degrees, alright? It means it must come from the x-axis. So it must come from this part. This is my x-axis. So the angle for vector A must be inclined to the x-axis. So I know that this quadrant is 90, so 60 degrees is actually inside of this first quadrant. So for vector A, 60 degrees, it will come from the x-axis. So from here to somewhere here, okay, let's call this vector A. Let's call this vector A. Alright, let's call this vector A, and the said vector A, the distance is 5 meters. So the distance of vector A is what? 5 meters, and this angle is what? 60 degrees. So I've actually sketched vector A. This is for vector A. This is for vector A. I'm also going to sketch the angle for vector B. So let's sketch the angle for vector B. For vector B is 6 meters at 130 degrees. So 6 meters at 130. Remember, we said if you want to sketch the angle for a vector, it must be inclined to the x-axis. So it means from here, the quadrant is 90. So from here to somewhere here, alright? Vector B, the angle is 130 degrees. So from here to somewhere here, let's call this vector B, and the distance for vector B is 6 meters, okay? So I've sketched that for vector B. Please observe something, Now, if you look at vector B, I know that each quadrant is 90 degrees, alright? So from here to here is 130. It means this remaining angle here, to make it 180 minus 130, it means this remaining angle is what? 50 degrees, alright? So the remaining angle is 50 degrees. Now, the same thing, vector A, I know that from here to here is 60 degrees, alright? It means the remaining angle, to make it up 90, from here to this other part, to make it up 90, this is 30 degrees, alright? So, there's a condition in adding two vectors that are written or represented in graphical form. You add the tail of the second vector to the head of the first vector. And my first vector is vector A, okay? My first vector is vector A, and vector B is my second vector. So I'm adding the tail of the second vector to the head of the first vector, alright? So you can perhaps put it this way. To the head of the first vector, we add the second vector. So let's add the second vector to the first. Alright? Considering the angles. Now I know that my first vector, vector A, this vector A is inclined at an angle of 60 degrees, alright, and this vector A, the distance is 5 meters. This vector A, this for vector A, alright, this for vector A, and they said to the head, this is the head, this is the tail, alright. In graphical representation of vectors, we add head to tail, alright, and not tail to tail, we add head to tail. So to the head of vector A, I'm going to add the tail of vector B. You don't add head to head, alright? You add head to what? Tail. So this is the head of vector A. I'm going to add the tail of vector B to the head of vector A. So to add the tail of vector B, alright, I can use my rule. This vector B, the tail of vector B, my vector B, alright? Call this vector B. This vector B, this is the tail. I added the tail to the head. And vector B, the distance is 6 meters, alright? The distance of vector B is 6 meters. Now, please consider something. I know that from here to here is 130. It means the remaining angle for vector B is 50 degrees. Now, if I draw a straight line, alright? If I draw a straight line, it means that this remaining angle here, is 50 degrees. This for vector B, alright? This remaining angle here is 50 degree, and the angle for vector A is what? 60 degree. Now there's something known as adjacent angles. Adjacent angles are the same, or you call them vertically opposite angles. Now look at this. Vector A, the angle for vector A is 60 degree. If here is 60 degree, it means this other part is also 60 degrees because they are vertically what? Opposite. Okay, so it means the angle for this aspect is 60. From here to here for vector B is 50. So if here to here is 50 and from here to here is 60, it means the total angle from here to here is 110 degrees. Alright, so the total angle inside is 50 plus 60, which is 110. And we're going to add, we always add head to what? Tail. So I'll add this head to tail. Alright, so I'm going to bring out this shape. Okay, so bringing out this shape, I have something that looks like this. I have something that looks like this. Okay, I have something that looks like this. And the angle inside is 50 plus 60, which is what? 110 degrees. And I know that this side, the distance is what? 6 meters. And I know that this aspect, the distance is what? 5 meters. So what I'm looking for is my resultant R, the distance from here to here. Okay, so what formula do we use? Whenever we have two sides and one angle, we use a rule known as cosine rule or parallelograms rule. Okay, so we use cosine rule. We use cosine rule or parallelograms rule. Okay, that's the two rules. Whenever we have two sides and one angle, we use cosine rule or parallelograms rule. And cosine rule says that our root squared is equal to a squared plus b squared minus 2ab cos theta. Okay? Our root squared is equal to a squared plus b squared minus 2ab cos what? Theta. This cosine rule. Or we can use parallelograms rule, which is our root squared is equal to a squared plus b squared plus 2ab cos 180 minus theta. And here our theta is 110 degrees. So you can decide to use any of that and you get the same answer. But let's consider cosine rule. Okay? So using cosine rule, using cosine rule, I have this as, to get my resultant, r squared is equal to my a can be 6 or 5. You can use either of them. So I have this as 6 squared plus 5 squared, alright, minus 2 times 6 times 5, and this is cos 110 degrees. Okay, that's cos 110 degrees. So finally, I have my answer as r is equal to 6 squared. 6 squared is what? 36 plus 25 minus 2 times 6 times 5 is 30. Then cos 110. So finally, I know this r squared. So to get r is equal to the square root of everything. 36 plus 25 minus 2 times 30 cos 110 degrees. So finally, my resultant, if you use your Casio FX, to do this so that it becomes faster, if you use your Casio FX, the root of 36 plus 25 minus 2 times 5 times 6 cos 110 degree. I'll be having something like 9.02 meter. So it means the resultant, this part, this side, the distance is 9.02 meters. That's the resultant. Alright, but we're not done. They said we should add the two vectors and we should also get the resultant and the angle. So what I've just gotten is the resultant. So to get the angle, theta, we use sine rule, and the rule is A over sine A over sine A is equal to B over sine B, okay? But here, we use sine rule when we want to get the angle. I want to get the angle, listen up, I want to get the angle. Now, some persons might ask, which angle are you looking for? I am looking for the angle that is inclined to the x-axis, the horizontal, alright? Because we took our angle with respect to the x-axis, alright? That's how we draw our angle. So to get the angle, I'm looking for this angle from this part to this part. I'm looking for this angle, okay? So the angle I'm looking for is this angle from here to here. That's what I'm looking for. With that angle, I can sketch my resultant diagram. So I use sine rule to get this. So I'm looking for this side. Call this place A. Alright, this place is capital A. This is small r, and this side is capital R. So using that, I know that my A, which is the side, is 6 meters all over my sine A. Sine A is this opposite side. So I have this over sine A, and that is what I'm looking for. And that's what I'm looking for is equal to, alright, B. What's my B? My B is known as this R. Okay? This side is what? 9.02 meters all over sine of 110 degree. So what I'm looking for is sine A. So to get sine A, please come here. To get sine A, to get my sine A, I'm going to wipe this off. So from that I have 6 meters over sine A is equal to 9.02 meters over sine 110 degrees. This is sine rule. We want to get this value of A. Okay, so cross multiply. If I cross multiply, I have that sine A times 9.02 meters is equal to 6 meters times sine 110 degrees. Okay, so to get sine A, we divide both sides by 9.02 meters. 9.02 meters. Okay, this will take off this. So I have this as sine A is equal to 6 meters times sine of 110 degrees all over 9.02 meters. Okay, so to get A, I'm looking for A, which is the angle, alright? So to get my A is equal to, when you divide both sides by sine, we'll have what's known as sine inverse, okay? Of, when you do this, 6 times sine of 110 all over 9.02. I'll be left with 0.625. So sine inverse of 0.625, second function of sine 0.625. So I'm left with, it means my angle A is equal to 38.68 degrees, which is approximately, let's call this 39 degrees. Okay, so my angle is 39 degrees, all right? And if you look here, my resultant is what? 9.0 meter. So to sketch the resultant of the addition of two vectors, the angle is 39 degrees. You draw your quadrant. 39 degrees is found in the first quadrant. Remember, it's always inclined to the x-axis. So let's say from here to somewhere here, this 39, from here to here, this 39 degrees, alright, and my resultant is 9.02 meter. So I can finally draw something like this. This is 39 degrees, and this is 9.02 meters. So this is the resultant of the addition of two vectors.